All right, so we're going to see a little bit about manipulating our quadratics so that we can recognize what's actually happening with a quadratic and also when we're completing the square. So let's just take a look at these three blocks that I have. The blue block is a square, and we already know that it has dimensions of x and x. So therefore this blue square has its complete dimensions of x squared. And you'll notice that on the green item, it is the same length as the square, so we know that either the top or the bottom is an x, and we can identify the side as being just 1 unit. If we move this yellow square up close to the green square, we'll notice that the yellow square is the same width or height as the green one, and so we're going to say that that's a 1 by 1, so it's just a 1. So now we have an x squared, we have an x, and we have a 1. Okay, so we need to be able to build this equation here. And so that means that we need an x squared, we just need one of them. We need 10 x's, and we need 17 ones. So I'm going to get all of that taken care of for us right here. Okay, so we have our x squared, and then we have our, which is right here, and then we have our 10 x's. So we have 5 here and 5 here, and then we have our 17 individuals. So this is all the stuff that we have to make this equation. Okay, so we want to make a perfect square out of this. So in order to take this equation and build it into a perfect square, we first get the materials that we've got here, and now we're going to rearrange these materials so that they make a perfect square. Okay, so we know that these green bars are the exact same length as our x squared. So we can just manipulate those so that they extend the height of our square by those 5 units. And we also know that these rectangles are the same width as our x squared because they're both x's. And so now we've extended not just one dimension, but we've extended both dimensions, and so we have this dimension extended by 5 and this dimension extended by 5. So with that, we're going to fill in this extra gap here with all of our 1s. And so as we're filling them in, now remember we have 17 of these, so we're just going to put all 17 in here. And when we complete putting all 17 in there, you'll also notice that we're going to have a little bit of a gap. And so we'll want to be able to figure out what that little gap is. Okay, so I have all the yellow blocks put in place. So there's all the 17. Now I'm going to just count the gaps by using this purple one, okay? So I filled in this entire square. We made it a complete square by just simply adding these additional 8 little squares. Okay, so I can't make a perfect square out of that equation, but I can make a perfect square if I take that equation and add those 8 to it. So now let's take a look at what we get when we add those 8 to it. We end up with an equation that says x squared plus 10x plus 25. Okay, so if you recall, this is a quadratic of a perfect binomial square. So we can factor this and it will become a perfect, it will show us that we have a perfect binomial square. So when we factor that, remember how to factor. The only factors of x squared are x and x. The factors of 25 are 1 and 25 and 5 and 5. So we have to pick a set of factors that when they add up equal 10. And so our factors are going to be 5 and 5. And we also know that since this is a positive, then both of the signs have to be the same, because positive 5 times positive 5 gets us 25, as well as negative 5 times negative 5 gets us positive 25. So the determining factor on that sign is that sign right there. So since that's a positive, we are going to have an add on both of those factors. So we have x plus 5 times x plus 5. So I eliminated a lot of that mess, and we just have this stuff that we need. Our original equation. Now we do have to recall that we added 8 to that equation, and then we got our two factors when we factored. And we can say that this is the same thing as x plus 5 squared, which is why we call this a perfect binomial square. Well, how does that relate to our little picture here? Well, if we notice, this length here we said was x. And this here, we added 5 ones, so we added 5. If we look at this length, we said that this length here was x, and here we have our 5 rows where we had our add 5 to our x value. So our width is x plus 5, and our length, or our height, is also x plus 5. And so we get the exact same thing had we factored this whole equation. And so we can see that it's a binomial perfect square, or it's a perfect binomial square, excuse me. So what does that do for us in quadratics? Well, we'll find that out a little bit later when we do solving using perfect squares. For right now, I just want you to recognize how perfect squares relate. All right, we're going to try it one more time just so that you can see it again. So we're going to create this equation first using our tiles. Okay, so we have our x squared, we have our x's, so we have 6 of those, and then we have our 2 1s. So now we're going to arrange these pieces to try to build a perfect square. Okay, in order to build our perfect square, we had to add 7 to it. And so now we have our perfect square, and we're going to rewrite this equation now that we've added the 7 to it. And you should notice again that this is a quadratic that is a perfect binomial square, because we can look to see that the c value is a perfect square, and its square root is 3, so the square root of 9 equals 3, and then the b value, or the linear term, the coefficient of the linear term, is 6, which is 2 times 3, which is 6, and that's what tells us that this is a perfect binomial square, because we can take our factors now. So x squared gets us x and x, because that's the only way to make an x squared. To make a 9, we only have 1 and 9 and 3 and 3, so we're going to use the 3 and 3 because they have to add up to be 6, and 3 plus 3 is indeed 6, and since the signs have to be the same, and they have to be the same as the linear term, we're going to put a plus sign in there. And so we again can see that we have a perfect binomial square because we have a square binomial that creates this equation, or this, this polynomial. But in order for us to have done that, we had to add those 7 boxes to it. So what you have to make sure of is to recognize that because we added 7 to our equation, in order to make it the same exact value, we would have to, when we add the 7, we would also have to subtract the 7, because otherwise we've changed the value. So when we look at this piece and we see that it, as we've seen here, factors to be x plus 3 squared, we have an x plus 3 squared minus 7. Now that minus 7 came from the fact that we had to add 7 to our original polynomial in order to make it a perfect binomial square, which then leads us to be able to write it this way, and you should all recognize that as the equation for a quadratic in vertex form, x minus h squared plus k. So we can easily find our vertex now off of that. It's going to be -3, -7. That gets us our perfect square, our vertex off of this vertex form that came from this original equation simply by completing the square and then contributing that -7 once we figured out that we had to add 7 to our original. Okay, that might sound very complicated, but once you do a few of these, they're going to be very easy. Okay, so let's try this one without actually using the tiles. So we know that we need the x squared. So we have that big square, right? And we need 22 x's. I'm not going to draw 22 x's, but remember we increased the length as well as the width by the same amount. So that increase on both sides is going to be a plus 11 on both sides, because we have to put the same amount over here as we do over here. Well, once we do that, now notice that we've just increased the x squared area by 11 in both directions, which means that we have this whole big area, which is an 11 by 11. And 11 times 11 gives us 121. So that means we needed 121 of those little boxes in here to be able to create this perfect square. Okay, so we notice that we only have 105 of those. So since we need 121, but we only have 105, we have to add 16 more. So we're going to add 16 more. And of course, whenever we add something to an expression, we need to subtract it so that we don't change the value of it. Now, the reason why we added that 16 is so that we can have this whole thing be a perfect binomial square. So when I rewrite that, I have x squared plus 22x plus 121, but we can't forget that we have this minus 16 that had to be put in there because in order to get that 121, we had to add 16 to that 105. Okay, now that we have that, we can find the perfect binomial square right here because we recognize that we have 121, its factors are 11 and 11, and when we add them up, it's 22, and it's a positive because this term is a positive. So we have x plus 11 squared. Now we can't forget to write that minus 16 here, And so now we can tell what our vertex is. Our vertex is just going to be -11, -16.